My name is Brynle Barrett. I'm a researcher here at University of New Brunswick. This is the Quantum Sensing and Ultra Cold Matter Lab, which was a new laboratory I established in 2021. People talk about the quantum advantage. That's because you can, in principle, you can push the sensitivity far below what a traditional sensor could measure. The instruments that this team builds in this lab are focused on making ultra-precise sensors using atoms. And there's a variety of techniques you can use to make sensors, make quantum sensors with atoms or molecules. But what we have chosen to do is to go to ultra-cold atoms, meaning we use lasers to cool them down to very low temperatures. And when they're at low temperatures, they tend not to expand very quickly compared to, say, room temperature atom, which is moving at the speed of sound. And so it just means that we can keep them and observe them for much longer than in a room temperature gas. So the idea is to use cold atoms to make very precise measurements of magnetic fields, very precise measurements of gravity. We don't see often instruments that are capable of using lasers to cool atoms to absolute zero. What can you do with them once they're there near absolute zero? I mean, the possibilities are through the roof. This sensor alone could, in principle, be used for mining operations, oil and gas prospecting, measuring the water table at the present time. There's a few companies in the world that have commercialized this technology. I worked with one of them in France. So I sort of learned a little bit of the tricks involved in making them feasible instruments to bring out into the field. And if you're able to do that, they actually have great potential for a variety of applications. Probably the biggest one is still in defense, but we could also talk about civil engineering. We could also talk about climate change impacts. In the north, where global warming is causing the average temperature to rise all over, it's actually 4 or 5 times faster in the Arctic, which is leading to rapid melting of sea ice. That sea ice then pours into the oceans, and local sea level rises much faster there than it does in, say, the equator. And so what effect is the sea level having on the landscape, especially in coastal areas where people live? There are a lot of indigenous communities that use the sea ice to fish. Those have real impacts on communities. So how can these sensors impact those communities? Well, if you were able to take them out on an aircraft and survey the land, both in terms of what's the magnetic field doing, what's the gravitational field doing, you get a better picture of the impact of climate change on the landscape. If we're talking about New Brunswick, there is the Bay of Fundy. These two instruments actually have the potential to sense the effect of the massive amount of water that's sloshing in and out of the Bay of Fundy every day, twice a day, and what its impact is on the landscape. So that's sort of a short-term goal, is to use these instruments to probe the effects of the Bay of Fundy and to tell us more about the tides in that way. It takes much longer to build these instruments than you think. You have to take into account the fact that students coming into this program aren't necessarily trained in the technologies or in the skills that are required to just make cold atoms. No, we have to train the students up, so it takes a lot longer to teach them how to do optics, how to do electronics, how to align laser beams, how to control the whole system, for instance, from a computer. You have to be a jack of all trades to work in this field. And so it's a big burden on the students to learn how to do all these things. And that just takes time. Quantum technologies aren't going away, just like artificial intelligence isn't going away. If you want to stay competitive, you need experts who know how to use this type of technology to build new instruments, new products. My dream is that Canada, someone picks up on this technology, that we have expertise here, and that we can build these companies that exist elsewhere. There are a few experts in Canada that can develop these sensors. And so I think that's where the real potential is for New Brunswick. It's an exciting new technology, bringing in students to train on quantum technologies for the first time. And as an industry that could potentially flourish and be commercialized in New Brunswick, there's a lot of potential.